You would like to know more about aluminium parts for your 3D printer. Maybe you even design your own parts and you would like to get them milled out of aluminium. But looking at prices and how expensive they can be, SLM could be a very good alternative. But can you drill and tap aluminium? I would like to answer these questions for you. Even look at some of the CAD files and things that you should think of changing before you order your SLM parts. We'll also go into the workshop and I'll show you how I was able to easily drill holes into the parts and even cut threads. Please stay tuned. After the intro, we'll carry straight on with the CAD files. Before I start talking about the SLM parts that arrive from PCBWay, I would first like to talk about the aluminium CNC part. Aluminium CNC part for 3D printers has been a fashion out of personal reasons, if it's more structural reasons, high temperature reasons, better print quality reasons. The reason why we are using aluminium parts and the boom for aluminium parts has just grown in the last 2 years. I would say since Simon from VZBot brought out aluminium parts for the VZBot itself, aluminium toolhead, aluminium gantry part, the trend has just exploded for any other printer out there to use aluminium parts. And my personal reason is for better structural components. High-speed printing, you would need better structural components, but also because I use water cooling, and water cooling is a part where I would like to conduct the heat through the part, through the aluminium part, so that it can be transported off with the water. I actually stopped using fans on my hot ends since 3 years now. I've had some very bad experience in the print farm where things just went completely south in 1 week, and that was the time when I stopped, or when I pulled the plug for air cooled and I only use water cooling. But that's personal again. Everybody should know their own reasons why they use aluminium parts. This part here is the back plate that gets mounted onto the X-axis rail. It's quite a complicated milling process to produce this part. All the green markings are threaded holes. You can also see one at the top. There are two at the bottom. This part would have to be turned multiple times to be able to CNC it in this matter, the way that it got designed. Of course, you can always design it differently, but I decided this is the way that I wanted to go, and also try and make it as light as possible. These top parts are for cables to go through, some more mounting holes if I wanted to mount something. That was the design that I was working on. To support the top plate, I made these left and right arms. They also have threads at the top, so you would bolt down the top plate with 5 screws to prevent bending at the tip where the hot end is. On the side are 5 holes, threaded holes, so the top 2 ones are for the main duct of the Mammoth toolhead. The bottom 3 are for different hot end duct positions that you can screw and bolt them down. Also quite complicated to produce on a CNC mill. To mill all these parts, you would have to turn that multiple times. At the top then, I decided to put a 4mm top plate. I haven't had the experience with the VZBot 3mm top plate bending or breaking. I've never encountered that, but I've heard a lot of people having problems with it, so I decided to make my aluminium version out of a 4mm top plate to give it that structure. Also at the top, I added in the back area some isogrid. This is where the Mammoth duct gets mounted on, just to make this part lighter. Some small holes for the end stops, some cavities. like we know on the VisiBot toolhead. Simon used something similar, just to hide the screws, the low profile screws, so that they don't interfere with the extruder that gets mounted at the top. This was the main idea, to produce the toolhead like this. Then I went out and I asked at multiple places, including PCBWay, to produce this. PCBWay, I think it's fairly simple. You upload your files, you get an instant quote. The quote for this, as we see it here, with the threads cut in, anodized in black, would be between $120 and $150, depending what options you choose. And I didn't want to spend that kind of money on a aluminium toolhead. I just think that is too expensive. I understand the price. I'm not against the price because it is a complicated part to produce. I then thought, okay, let me ask some colleagues in Europe if they would be able to produce this part, and everyone so far has said no. It's too complicated and it's going to be too expensive to produce this part. And that was actually the reason why it motivated me to test SLM printing out of aluminium. Again, I need it for water cooling reasons. And I actually made a little brother of the CNC part, which is I call it the SLM part, of course, because it got SLM printed. It looks very much the same. These top cavities are missing because this is one design. This is not in multiple parts. It got designed as one part because it would get SLM printed in one part. And I reached out to PCBWay, asking them if they would be interested to help me produce this part, if they would be interested that I produce this video that we are watching now together. It's my first SLM part. I've never ordered SLM before. I've never worked with a material before. I've worked with lots of aluminium. I know how to drill and tap it. I don't know if SLM is the same. I have not drilled and tapped anything yet. We're going to actually do it together, and I'm going to put it into the video, my experience. If I break it, which I don't hope, then I break it. And if it works out, then this is a learning curve. I think a lot of us can learn together. Again, the part got made even lighter. If we look at the isogrid, I added a lot more isogrid at the top. I was able to add chamfers into the parts, which I didn't do by the aluminium parts or the CNC part. The walls are thinner. Now the wall is only 2.5 millimeter instead of 3. I was able to design this part a little bit thicker, so still 3 millimeters to have the structural support for the threads. Something small, if you ever design something like this, or you have an aluminium version that you would like to SLM print. Here we can see the router bit that would cut into the material over here, just as an example. On the SLM part, I did remove it, so they are not there anymore. Also, you will see if you order SLM parts that they say the wall thickness should be a minimum of 0.8. I aimed for 1 millimeter wall thickness just to make sure that everything is structurally strong and doesn't break, or the aluminium doesn't break, because of not having the experience with a SLM part. But I was definitely able to add more isogrids at the top. Overall, the finish of the part looks like I would design it for a FDM printer. It just looks nicer, neater. Was able to add my logo at the top. I also have the holes at the bottom. I did not order the parts with threads cut in. I wanted to get my own hands on there and get my own experience. Maybe next time I will order them with threads already pre-cut. A very good colleague of mine that does a lot of SLM printing for his own printer advised me to use helicoils and not to cut threads into the SLM part. It just makes it durable over a longer period in time. Again, he's got some more experience than me. I don't know, but I'm going to put helicoils in. That's what we're going to do as well in this video. And yes, that's the SLM part that got designed and produced by PCBWay. I would also like to say thank you for PCBWay for sponsoring the parts. They did sponsor it. I am not going to try and break it, but we're going to try and work on it. And I believe if it would really, like I was told, it would work. I think this is a better solution than the CNC parts. Why? It's out of aluminium. You can make your design even lighter than the aluminium version. It can conduct heat, and the price difference is huge. On the left, again, is the CNC part that would cost at PCBWay around about $120 to $150. In Europe, nobody wants to produce it. So if you produce or design something complex, it's going to be difficult finding the right person to do it. Of course, you can give it to a company to produce it for you, but then we're probably talking $500 and upwards to set up the CNC to cut it for you. And the SLM part on the right with the logo on will cost $30. Yes, $30 at PCBWay. This is not, I don't have a discount code to give you guys. If you register at PCBWay, which I know, you get a $5 discount voucher. But yeah, 30 bucks. And the quality, if we look at the part, is just beautiful. It's got this little sandy look on it. But it's smooth. It's just the look. I was thinking to put it in a tumbler, but I thought, for what? It's smooth and it's out of metal. It will conduct the heat. So at the moment, I'm not even going to do that. I'm going to leave it as is because I think it looks beautiful the way that it is. So I don't want to spend too much time in the CAD file. Going to the workshop where the toolhead is now. We'll have a look at it before I start drilling and tapping into it, what it looked before and after. And then we're also going to mount the part onto the 3D printer to see how it performs actually on the printer. And like I said, stay tuned, because if you leave now, you're going to miss something beautiful that PCBWay made out of SLM. Got some tools ready on the CNC bench. I thought this is the easiest place to film and work on these parts. The workbench, as we can imagine, it's just busy. A lot of parts lying there, which I don't want to reveal today. Before we start, like I mentioned earlier on, this is the hybrid version, which consists out of 3D printed parts and the VZBot top plate. I made this design about 2 years back, and that I use on and off for the water cooling. Works brilliantly. Then just a normal VZBot top plate. This is the old version, still with all these holes in between. The new versions don't have that anymore. And then the part that arrived from PCBWay that just looks absolutely beautiful. The logo at the top. Then the inside, all the ISO grid. If you look at the detail on it, it's just, it's unbelievable. I mean, the quality, I did not expect SLM to look like this. I hope it zooms in. So yeah, this is the part that we're going to be working on. Something that I did notice, which is worth mentioning, I did work on a tolerance of 0.05, and it is too small. So some of the holes are too tight, but this is not PCBWay's fault. This is me not knowing how to design the part properly. I will definitely, that's a learning curve. I need to get something printed again with more tolerances, maybe a 0.1, and test if a normal 0.3 millimeter screw will screw in. I will definitely reach out to PCBWay. Maybe I can speak to one of their engineers just to find out what the best design tolerances are so that parts fit better. Then I got this helicoil set in 3mm and 2mm. The reason why I don't use the Chinese ones, I do a lot of modding, I do a lot of changes, and I just want to be able to buy parts in Europe and not always have to ship them over from China. So this kit was like $80, definitely much more than what you would buy off a normal kit. But what I liked, and I just didn't have time to source it to get this video out, was on the bottom over here. It comes with 3 different sizes. I had problems finding the 1Ds in Europe, and these guys, I can buy hundreds of them in Europe without a problem, so that's why I decided to use it. And like this, I always have a constant size. I don't have variables in sizes, so that's why I decided. But again, I know you don't need to use these helicoils. You can use also aftermarket ones or different other ones if you can find them. So before I start drilling into the SLM part, let's just choose a corner here. I thought let's drill into a piece of aluminium and just see what it's supposed to look like with a 3mm drill. So now with the WD-40, you don't get those spiny pieces, but this is what it looks like if you drill into normal aluminium. And this is what I want to compare what the SLM is going to look like. So got quite big pieces over here, and I would just like to compare this to the SLM part. So yeah, I've got it now just on a little work block. Some of the design parts that I did, because when I designed this, I thought I was going to cut and thread, and only got changed. The plan only changed later. So this bottom hole here, I am very nervous to drill in there, 3.2mm hole. I'm scared that it will break out the bottom, so I will see if I will put a helicoil in there. I don't think I need that, but I will definitely have to change that for the design. And also I decided now to maybe use this hole up here, that one there, just to test it, to see what the outcome is going to be. I'm going to add some WD-40. I normally add oil, machine oil, or things like that if I drill or tap aluminium, so just that it stays lubricated. And let's try and drill this that you guys can see. Okay, and what we are after is to see what it looks like when you cut it, and it looks exactly the same like I would have cut, or like before, the aluminium. It looks like aluminium that I just cut. And if I take, because I used the 3mm drill bit, and I put it in, then my 3mm screw fits in perfectly. So I'm actually a little bit less nervous. So let's get this drilled up, and we'll see what the end result looks like. I pre-drilled all the holes where the helicoil is going to go in with 3mm. So all of the top ones got drilled. These ones here got drilled. Those ones, that one there at the back. All of the 5 on the side. The bottom one actually turned out okay. I think there's enough material there. on this side the same, and then all of the holes inside here where I'm going to put helicoils in got drilled out with 3mm. The next size I'm going to drill with is 3.2, and then cut the thread into the holes. But that's what I did now, just preparing the part for the next step, drilling 3.2mm and then tapping for helicoil. So after drilling now all the 3mm holes, I'm going to take out of the helicoil kit the 3.2mm drill bit and just place it onto the drill. I'm also going to hand drill these. And let's try and just put one helicoil in. I'm so curious how this is going to work. I think that is a good spot to show it. So let's just drill in one at the top. Just give it oil. Can never with aluminium have too much oil, but not enough oil. So that is 3.2mm. And then I found this little adapter. I just quickly printed it. This is a thread cutter holder, 5 to 7mm at the one side, 2.5 to I think 4.5mm on the other side. I found this on Printables. I think the team that made this is called Bam Bam Labs. I've never used this before. Like I said, I just downloaded it. So the thread cutter actually fits nicely in there. I normally take the drilling machine and I just drill threads in, but let's do it the proper way and not break anything. Give it some juice. Okay, I have to say the thread cuts very, very easy into the SLM printed aluminium part. And I'm turning this in with 2 fingers. Just clean this off. So there you can see the thread has been cut in. And now I'm going to take the little tool that is in the set. This is to install the helicoil. This is also something I have never done before. This guy sits a little bit loose in there. And then I'm going to use out of the kit, you have these 3mm helicoils inside. So I'm just going to remove one. Okay, there we go. So you have to thread it in. See if I can zoom in. So that's what it looks like. And then it should thread into this part over here. I can turn this in with my hand. I don't even really need a tool to do this. And you can see it's flush. Okay, very easy to do. That is flush. And then in the kit is another tool. This is to break the little pin off that is inside of the helicoil. You can see that little pin. So this part should go in there. Just see if I can grab it. Or I think you just hit it. Maybe I should read the instructions like we all do. Very bad. Yes, you just press it in. And now that little metal piece is gone. So the helicoil is installed. And if I take a normal 3mm, make sure we are zoomed in here. Okay, just a 3mm screw. There you go. Oopsie. There you go. That's what it's supposed to look like. Super easy. I'm so happy. The process of making this is so easy. I always think about FDM 3D printed resin parts that are brittle or break easy. But this was so easy to do. And again, the part is so much cheaper than if it's CNC'd. The SLM part we saw makes these nice little chips if you drill it. So the same like normal aluminium. And I think from here it's just going to be a breeze to put the rest in. So what I'm going to do is drill my 3.2mm holes, put in the helicoils. I'll probably fast forward the video that it's not so boring to watch, but I'm going to install those and then we'll have a look at it once I'm finished and done with it. Looking at the final result of the SLM part, drilled, tapped and helicoiled, I must say I'm very, very happy with the outcome, what it looks like. Even these screws down here at the bottom, I did not expect this to actually work that good. It was very easy to drill, tap and put the helicoils even in these where the walls were very, very thin. At the back, also in total, there are 30 M3 screws and 2 M2 screws. I don't know why this back one is so skew, but I guess I wanted to show the possibility to do this by hand drill and not the table drill. So I guess I just drilled that a bit skew, but for the end stop that is going to get mounted, I don't see a big mechanical problem there. Nothing out of the ordinary, nothing to report. And I guess the big question is, would I order something like this or this part again? And my answer is 100%. And I guess the big question is, would I order SLM Aluminium again? And the answer is absolutely. I can't wait to finish the toolhead. I think it's going to look awesome when it's done. It's super light. I'll blend in the weight, how much it is. I'll put it on a scale without the screws so that you guys can see how little this actually weighs. But yes, a beautiful part, how it turned out, and I can't wait to mount this onto the printer. Please consider subscribing and hitting that like button. That would really help the channel, excuse me, as this is still a growing channel. So the channel can really benefit from your likes and your subscriptions. In our upcoming video, I'm not gonna extend this video much longer. I think it's enough was said, enough was shown that SLM can be drilled and tapped. But in our upcoming video, I'm going to show for what this part is. It's also SLM printed out of aluminium, also from PCBWay. And if you know for what this is, drop a comment below and let me know if you can guess for what hot end this part is for. I can show you now already. It will be mounted at the bottom like that. Okay. And then also, I don't know if it's going to be in the same video, but I'm going back to the roots, back to the Mammoth toolhead. So this is actually the carriage or the toolhead for the Mammoth duct. This got modified and reduced, or the height reduction, by 13 millimeters, making it even lighter. And I will also show you in an upcoming video how this gets mounted, what the idea is of this, and the combination that I'm planning for this toolhead. Thank you very much for watching till the end of the video. I really do appreciate it. And again, please leave your comments. I will try and answer all of them, and I'll see you in the next video.